Hi, this is On Imagination with the Ethical Asshole. I am your host, the Salty Bitch. Now, I'm going to go ahead and dissect this. This is very different from something I do. Usually I do these live on Zoom, and then I pull up my documents and I go through my documents and I do my own science focused in my little realm. But I'm going to do it live this time. I never do it live, and I am 100% in analysis mode right now. 100% of everything I am saying in this video is hypothesis. And it is just me finding a logical fallacy going, I got to figure this out because the logical fallacy is screaming at me and it's bothering me. So I am looking at cell mitosis and cell apoptosis. I'm also looking at integration disintegration. And when I first looked at cell apoptosis, cell mitosis, I went, oh, they're opposites. No, they're not opposites, not at all. This is really where it gets interesting. Cell mitosis is literally the disintegration process. Now, disintegration, and this is why words matter. Disintegration does not mean dissolving. And this is the problem. Dissolving means to literally, dissolve. It means to unsolve something. It means to deteriorate the point of solution. And that's what we are seeing with dissolving. So cell apoptosis is actually dissolution or dissolving. It is not disintegration. Disintegration is the undoing or the reverse of integration. So in disintegration, and then you have integration. And then you have cell apoptosis, which is dissolution. Now, this is where I'm looking at cell mitosis, cell apoptosis, going, these are not the same thing. These are not opposites, not at all. Because cell apoptosis is dissolving, not integrating, disintegrating. Cell mitosis is disintegrating, integration. So there's no opposites going on here. And this is where I really want to take a look at this. Now, if you look at cancer cells are actually integration, disintegration. So a cancer cell is more related to cell mitosis. Yeah, it is. Cancer cells have more relativity to cell mitosis than cell apoptosis. Cell apoptosis is a completely different process. And that is where I was getting confused, is because biologists are not linguistics or logicians, and it shows. If they did, then they would know that the cell apoptosis process was not opposite of cell mitosis. They would have caught on this further and gone, wait a minute, this is a completely different process. But they didn't study integrated mathematics either, or they would have figured this out. So this is what I'm looking at. When you have your sperm and your fertilized egg, this is when you have two integrated wholes, and those both are these are 2 points, and they integrate into one whole, which is the fertilized egg. And that process of sperm and egg are the integration process. Now, once the cell is fertilized, it starts the disintegration process. Now, I want to clarify that disintegration does not mean dissolving. Disintegration means the undoing of integration. And that's what it's doing. It's like unpackaging it. So it's not integrating, it's de-integrating. When it de-integrates, the 1 becomes the 2 becomes the 4 becomes the 8 becomes the 16. And this is where they would use the term multiplying, but it's not multiplying, because multiplying does not have independence with the point of origin. That doesn't even begin to make sense, because what you're looking at is, let's say, it's the difference between, I draw a circle here at the top, 1, and then that 1 branches off to 2, and then it branches off to 4, and then it branches off to 8. Multiplying is like putting it in a multiplier, and you're making copies of the same thing over and over again. So you end up with one independent piece of paper that I put inside a copy machine, and I multiply it, and that becomes 20 pages. The 20 pages it's now multiplied, but it's literally independent. So again, this is really, really important, that disintegration integration focuses on the independence dependence, whereas quantity is all about independence. It's really, really important. So it's not multiplication. It is absolutely integration, disintegration, but it's not breaking it down either, because breaking down is dissolution or dissolving. So in cell apoptosis, it's dissolving, which is a completely different process that doesn't even fit into this entire pattern of integration, disintegration. The integration pattern is you have 1, and then you have 4, and then you have 8, and then you have 16. And then after you have 16, you have 32. But then the disintegration process is 32, and then 16, and then 8, and then 4, and then 2. There's that sperm and that egg again, and then 1. So disintegration or integration inside the body happens when the all of you gets compacted into a single egg or a single cell. It's the seed. And that's really what we're looking at, is we are looking at the seed to the point of unwrapping the seed. And this is called, give me a minute, I have to step over to biology. Oh, we know germination. This is the germination would be the fertilization. No, it's not. Germination is after fertilization, you have germination. So this is actually the germination process taking place. And then you have the production or that fertilization afterwards, where it then develops seeds again. There's no name for this in any biology anywhere. Let me look up plant fertilization. I don't think this has a name yet, which is why there's confusion, is because they've merged incorrect phrasing and incorrect grouping. And as a result, we haven't been able to give things their proper name. So you have seed, and then you have germination, and then you have the integration, and then you're back to a seed again. And that's it. Plato's point, disintegration, integration, and then Plato's point again. So when a plant grows, by the way, the germination process is the growth process. And then you've got this split, this divide. That's what I refer to as the mirror, by the way. That is the mirror that I refer to in all of my work. That is the mirror that Carol Lewis is talking about in Alice in Wonderland. He figured this stuff out. So on the other side of the mirror, through the looking glass, you have the integration process, where all of the defined integrated components are now collecting back into the one seed. So this is what we see in the learning process when Dad buys you a radio and you say, I'm going to take it apart. And you take it apart and you disassemble it, disassemble. Now that is disintegration. You are disassembling it. And then after you disassemble it, you go, wow, that's how it works. And then you put it back together again. That is the integration process. And it's a radio again. If you did it right, there should be no leftover components. That is what's going on here. That, by the way, is the learning process, which is how we learn, is through reverse engineering and then engineering. This is where teachers really mess up their job, is they just teach us construction. But you can't. You have to do deconstruction to do construction. So deconstruction is the germination process of the learning process. And it is vital to you learning how to do things. It's reverse engineering. You must reverse engineer before you can engineer. This is the way. This is the way our brains are. We have to do this. You must reverse engineer, and then you've got a seed again. And once you have seed, now you've got the point of comprehension, which is why I refer to this as the point of comprehension, is because you've been integrated back into the point of comprehension, and now you're a master. Now, an apprentice is only in the reverse engineering process. A tradesman is only in the reverse engineering process. The master is the one who is in the integration process. Only a master is in the integration process of learning. Teachers are only in the reverse engineering disintegration process very early on, and they never make it further than that, because that's usually when they stop learning, because they start teaching, and when you're teaching, you're not learning. So you've got this point. That is true. When you are teaching, you are not learning, because when you're learning, you have to be listening and observing. But if they're talking, they can't listen and observe because they're talking, which means teachers never learn, which is why I hate teaching. So, which is why I went over to writing. So you have basically apprentices and tradesmen are in the first part of that reverse engineering process. And then you've got that divide. And then with the divide, then you switch over and you become the master. But the mastery takes time. Immediately, you don't switch over and boom, I'm a master. You are an apprentice master. It's not until you've mastered mastering, you have to master the master stage in order to be the master. So when you are an apprentice master, that's when you start teaching. But it's not until you get to the end of this, when you become a master, when you've mastered the master stage, that you are the master. Then you begin the next stage, which is expert, which is where I like to call philosopher. That's where the philosopher stage begins. That is literally the philosopher stage. After the philosopher stage is the sage stage. And then after the sage stage, you get into magi. Oh, let me think here for a minute. Genie, magi, logi. Those are your next three levels beyond that. That's way beyond that. Most people are in the apprentice tradesman skill level. And like I said, mastery is now what happens when you hit mastery is you have all the defined components. And that's what happens. You have defined components. And when you have the defined components, you start integrating them. And then you get, so let's say you have 10 defined components. You integrate them. Now you've got 9 defined components. This is a generation. Then you integrate them again. Now you've got 8 defined components. Integrate them again. Now you've got 7. Do you see the pattern? This is the pattern. 7 defined components, and you integrate them again. You got 6 defined. This takes time. So when you finally, by the way, if you look back through all of my documentation, This is why I'm like, I've integrated and I've got some new words, but I'm only at 6 integrated points. And then I integrate again and I got 5. I integrated that. I can say this again, but I'm only at 5 points of comprehension. I have to do this 4 more generations. You can watch me go through this process. So I integrate the 5, it becomes 4. I'm down to 1 now. Finally, which is why I can say, oh, there's 2 kinds of integrated mathematics. There's integrated and there's summation. Yesterday, I went up again. I elevated again. Now I went into the next generation. I went, that's eureka. That's the eureka moment, is when I finally am done integrating all of them. And I go, I understand it now. Now I understand it, because finally I am at the point of comprehension with integrated mathematics, which is why I'm finally able to figure out why cell mitosis and cell apoptosis have nothing whatsoever to do with each other. Is because you have to be at the point of comprehension of mastery of mathematical integration in order to spot shit like this. Shit like this. That sounds like a great title to a podcast. Shit like this. So when you work your way through, and you can mark it, there is absolutely like mathematical frequency. This is frequency. This is perspective. This is dimension. It is the known or visible components available to you of comprehension at your generation of sequencing. And once you integrate, you move into the next shift, and then you have to integrate. But in order to do that, you have to know how to see and identify all of the components available to you at your point of comprehension, at your point of perspective. But you're not going to know it. You're not going to be able to figure it out until you've condensed it and you have figured it out. If you do not understand how to do this, you're going to have a really hard time doing problem analysis, figuring things out, seeing your whole situation. You're going to get stuck inside the bubble trap, where so many people live inside the bubble trap. If you live inside the bubble trap, get out. The bubble trap is not good for you. The bubble trap is bad for you. So many people live inside the bubble trap. The bubble trap is when you live inside the point. Inside the point. It's like you're in a balloon, a very small balloon, and all you can see is the wall of the inside of the balloon, and you think you know everything, but you're inside the wall of a balloon, and you're not going to understand that you're even inside the wall of a balloon, because you are inside the wall of the balloon. Do you remember Men in Black, when they had the galaxy, and they were inside the galaxy, and you were an invisible point inside the invisible point, inside the galaxy, inside the little marble that was on the dog's leash? That's the bubble trap. And you have no idea that you are inside. This is the whole point of Men in Black, is you have no idea that you are inside the bubble trap. And then the Matrix takes you outside of the dog's leash, and that's going, aha, look, now you're on the outside of the bubble trap. Like, I could do a movie where it's like Matrix and Men in Black merged together, and like I can see it, where he gets out of the Matrix again. And it's like, oh my God, I was inside the dog's collar the whole time. Like that's what we're talking about here, people. This is really deep shit. Welcome to ontology. So once you realize that you are outside of the bubble trap, you get outside of the bubble trap, and then you can start to see the order of operations of, oh, this is where you have to be in order to see mathematical integration. Is you have to be able to see the different levels of sequences so that you can start combining them and integrating them so that you get to the point of comprehension. And once you're at the point of comprehension, you get to see the ultimate picture, but only on this level, knowing that there's going to be a bigger, because you're just inside another bubble. That's integration mathematics. You're just inside another bubble. That's a beautiful part of integrated mathematics. So the question I now have is, what is the relationship between dissolution and disintegration? Now, that's what I want to know. And that is my next research project. What is the relationship between dissolution and disintegration? Now, I got to say this because this is so important. I never, ever create an hypothesis and then I do research. That is the dumbest thing you can do, because that's where confirmed bias comes in. But when you ask a question and then you begin your scientific method, that actually ignites curiosity, wonderment, and an open mind. Your RAS starts to go, and your RAS, that's your reticular articulating system, starts to zoom around looking for like a massive, it's like looking for seashells on the seashore. Like, I'm looking for seashells on the seashore. And you just span your mind wide open. That's your RAS working for you, because you are asking a question. If you have an hypothesis, you go right back into the bubble trap. Hypothesis, opinion. Opinions are a death sentence. Don't do those, because they immediately close your RAS. Now you've got closed-mindedness. This is where it comes from, because you've closed your RAS. You do not want to close your RAS. Questions open your RAS. So never start your scientific method using an hypothesis. Never, never, never do that. You want to always make sure you are using a question to open your RAS so you can look for seashells on the seashore. So questions. So my question now is, what is the relationship between dissolution and disintegration? That is my next science project. If you want to check out any of my science, it's all over my website, annaimagination.com. It's under research, and then it's just boom, all of my ideas. And it's all of my research. It's videos like this. It's all of my graphs. It shows you how I do all of my logic, math, physics. It's all of this. There's a lot of integrated mathematics there. Thank you so much, and may the kindest of words always find you.